That's right. Take 5. This is now the 5th time I've tried to make this video. I've spent more than an hour making this one video when it should only be a 15 to 16 minute video. So we're going to try again. As I've said many times, and as my poster in the back of the room says, expect me to make mistakes because I make them. And when I thought I copied and pasted correctly and had the right answers, I keep getting through the end of the video and finding out, oh, yeah, that was wrong too. Let's try it this one again. Chapter 8.9, Inequalities. And some of you are thinking that's the same picture as yesterday's video, and you're absolutely correct. We retaught inequalities yesterday, and today is now writing inequalities. Here's the big difference. So yesterday we talked about making sure we understood the arrow points to the smallest number and what some of the terms mean and how to show it and how to plot it. And now we have to do something that some of you really hate and despise doing. In the greatest wisdom of one of the most famous people in American history, we have to think, think, think. Yes, the beloved Winnie the Pooh, one of his famous lines and quotes in his movies and books. Think, think, think. A.A. Milne was known for saying those statements. Think, think, think. It's what we have to do. We're going to have to read. We're going to have to think, 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 and then apply. You know, in my reading class and all the stories that we talk about, from the small books to our trade books to our student books, we read it, we think about it, and we apply it. In science, we read it, we think about it, we apply it. And in math, some of you are skimming it, grasping at rotten stuff, and trying to apply it. And it doesn't work. It's like going into this candy shop where there's all sorts of wonderful and horrible things. And you see it and you think it looks good, and you throw it into your bag and you pop it in your mouth, and it tastes like a skunk. If it's not important information in mathematics, please don't use it. There's no point to it. Let's look at what we're talking about. Thinking about what it says. So we have the South Pole. Because of this information, please understand, I will never go there. The highest temperature ever recorded at the South Pole was 8 degrees Fahrenheit. The highest temperature. It never gets above 8 degrees Fahrenheit. That's redonkulous. Write an inequality to show that the temperature T in degrees Fahrenheit at the South Pole is less than or equal to 8 degrees Fahrenheit. So once again, inequalities. Inequalities. The way it sounds is its definition. It's not spelled the way it sounds, but inequality. Any number that can be held true according to the information. And the information that we're talking about is greater than, less than, greater than or equal to, less than or equal to. Have to know the signs and what information we're being told. So we're going to look at story problems, or we're going to look at sentences and figure out what to write, and then we'll talk about solving them in the next video and the next 2 lessons after that. I want to be asking these questions. So on my board over here where you turn in your lunch markers, I've had that same picture for several years now. When we're reading, even math problems, we have our reading voice. We're reading the words. But we also have a thinking voice. We're paying attention. We're engaged to what we're reading and what we're doing. And good questions pop into our head. As I'm reading this, if I think, oh, snow cones. I love cherry snow cones. That's my distracting voice that has nothing to do with what I'm doing. I should be asking, well, what's my biggest number and what's my smallest number in this math problem, so I know what I'm getting ready to set up. So when I look at the information given, I know the highest temperature is 8 degrees Fahrenheit. I know the smallest is going to be T. It's got to be equal or smaller to. How do I know it can be equal to? Because the information tells me that it's going to be less than or equal to 8 degrees. So what has to be smaller? What has to be larger? Which way is it going to point? Well, it tells me the T that we're talking about is equal to 8 degrees, can't be above, could be equal to 8, it's the record, but it could also be less than. So my arrow has to point to my T for a smaller number. It's underlined because it could be equal to. So my smallest has to be whatever temperature I'm talking to or equal to. My largest is 8, the highest recorded temperature. Yeah, once again, I'll never go there. So when then I talk about it, then I know that I have T is less than or equal to 8 degrees. Now, do you solve for t? No. If I was plotting it on a number line, could my t, my temperature, be 8 degrees on some day that you decide to go there? It could be, yeah. Could it be -2? It could be -100. Unlikely, but could be, because it's anything that is less than or equal to 8 degrees. But it could not be 10, and 10 is still cold. On the second example they give you, the directors of an animal shelter need to raise more than $50,000 at a fundraiser. Write an inequality that represents the amount of money, M, in dollars, that the directors need to raise. So if they raise exactly $50,000, have they met their needs? No, because it says that they have to raise more than. More than what? $50,000. So I have to think about what it's telling me. I have to ask the questions, what has to be smallest and what has to be largest? Well, the smallest that I can go is the $50,000. I must raise at least $50,000 plus 1. So 50,001 could be an answer. 50 million would make some very happy directors and dogs and animals, but it is a possible answer. So when I look at it, I know this is my largest, this is my smallest, and therefore my arrow has to point where? It has to point to the smallest number, which is 50,000. So M is greater than $50,000. And that is my inequality. That's my answer. That's what we're doing on this lesson. Writing inequalities and figuring out what it's saying. I have to think as I'm reading and be engaged. And stop picking that skunk candy to eat because it's just messing you up. I want to read this. Let's see, the elevation E is greater than or equal to 15 meters. Now, the way I do this is I read it, I think about what it's saying, and I write it down. All right, the elevator E is. What is? Well, E is. E is what? E is greater than or equal to. So I have to think about what that symbol looks like. If E is greater than, and my reminder is it points to the smallest number, then I know it has to point away from E, don't I? So E is greater than or equal to. So I put my line underneath the symbol. E is greater than or equal to what? 15 meters. So I write that down. And then I realize I'm done and I'm ready to move on. 2. A passenger's age must be more than 4 years. What must be more than? A for age, right? Because that's what it says. A is what? Well, A must be more than. So once again, it's bigger than whatever I'm asking about. Arrow points away. So A is greater than. Can it be equal to? No, because it says must be more than. So I can't have an equal sign underneath it. A is greater than what? A is greater than 4 years. I write it down. That's my answer. I move on. This one, well, I have to read what it says. And some of you don't like reading it and saying, well, that says greater than or less than. And I'm fine with that, as long as when I actually write out the word sentence that's required here, notice I said word sentence that's required here, then I'm good with it. So if you just say, well, I know the arrow points to the smallest number, fantastic, great way to start. So arrow points to the smallest number, so B is smaller than 1/2, right? So now we substitute those math terms. It's either greater than or less than, and you said it was smaller, so B is what? Well, it's pointing to the smallest number, so that's the less than, right? So less than what? Well, that's 1/2. So I write 1/2. And you're done. And we're moving on. M, something, 55. M is something. Well, what is M? Well, M is, and the arrow points away from it, so it's larger. So then the math term that we use is greater than, or it's underlined also. So, or equals. So M is greater or equal. Greater or equal to what? It says 55. So I write to 55. And then I'm done. Moving on. Question 5. Explain. Yes, that word means to write words in a sentence, to give me an explanation. That's what I will expect. Explain the difference between t is less than or equal to 4 and t is less than 4. Those look a lot of the same, don't they? T and t, less than, 4. Is there a difference? One little itty bitty difference, right? That line underneath the less than sign. And that line underneath on the first one tells me that t could be equal to 4. So, my explanation, here we go. In the first, t could be equal to 4. In the second one, it cannot be equal to 4. Not a difficult explanation, is it? But something that you can write down. So I stood back to, hopefully it'll show up a little bit better. For some reason when I stand in front of the light, it kind of whites it out a little bit, but there you go, it's nice and dark. Now, if you don't have it written down, pause the video, and then come back and unpause because I'm moving on. A children's roller coaster is limited to riders whose height is at least 30 inches and at most 48 inches. Write 2 inequalities that represent the height of riders for the roller coaster. Now what I'm going to do is I'm going to take it a step further, because 3 years ago, it was either 3 years ago, maybe 2 years ago, when we were first testing on the I-STEP on inequalities, they put in a double inequality, which is not even a 6th grade standard. But I don't want you to be, completely confused. If you happen to see one, if you think about what it says, they're pretty easy to understand. It just means that I have 2 limitations that I have to meet. I'm going to start first by just understanding the 2 limitations first that they give us. So they give me one requirement and another requirement. So the scenario, I'm walking up with my family to go on a roller coaster. My youngest is this tall. And the stick says they have to be this tall. They don't get to go on the roller coaster. They go off crying because they don't get to ride. But the second one says, hey, Dad, you can only be this tall, and I'm this tall. I don't get to go. So I go crying and hold my daughter's hand. So I have 2 limitations and therefore 2 inequalities that I write as my answer. First one, h, my height, must be at least or could be greater than 30 inches. So h is greater than or equal to 30. I've got that one, so I write my second one. My second one says, my height must be equal to or less than 48 inches. If I'm 48.5 inches, I don't get to go on the roller coaster. I'm not 48 inches by any means. So h is less than or equal to 48 inches. Those are my 2 answers. Now, here's what you could see on the I-STEP. Now, please don't just say, I don't care, and move on. Look at this and think about it, because it's really not difficult. It just looks, when it first pops up, oh my word, that's really hard. It's not. So when I look at a double inequality, I have 2 requirements that have to be met. These 2 inequalities that you just wrote is right there. They're just put together. If I go to the center where my variable of h is, my letter, then I can read it. H is on this side of the arrow, so it's not being pointed to. So h must be bigger or equal to 30 inches, which is exactly what I said here. So that's good. But when I go back to my h and I look at the second requirement, it must be equal to or less than, because it's being pointed to, 48 inches. And that's what it says there. A double inequality is not difficult. I look at my variable and I see what the requirement is. And I can do that. Not difficult. It just means that from here to here are the only people that get to ride on that roller coaster. Anyone up here? Nada. And anyone down here is crying and holding a hand over there watching everyone else ride. Going on. Number 7. So when I read these, some of us want to automatically insert different letters. So I think they're just trying to trick you by having different letters that don't match up here at all. Or maybe they're just saying, hey, I want you to think about what this says instead of trying to match up a letter. We're going to go down this order and match them this way, which is usually the opposite of the way I do. Normally I take my word and I match up a definition, but I can read this and get an idea what my inequality is easier than trying to read my inequality and then trying to find a sentence that fits in. Walter sold more than 10 tickets. So I'm going to think. He sold more than. So my thinking question, which is the largest number? The tickets that he sold is larger. So my arrow points away from it. And on the other side is going to be 10. Could he have sold 10? No, because he sold more than. So I know it's going to be something which is greater than 10, not equal to. And so when I look at it, something greater than 10 is directly across from it. Well, that skipped ahead, didn't it? I guess I messed that one up after all. Anyway, it's straight across from it. Guess where the next one is? Well, we're still going to work through it. Fewer than 10 children are at the party. Now, if your parents are like me, they're hurt because you're upset because you invited 20 people, but secretly rejoicing because there's less than 10 there. However, whatever the case is, there are fewer than 10 children at the party. So, could there be 10? Can't be, right? It has to be less than 10. 9, 8, 7, 6, 5, 4, 3, 2, 1, or sadly 0. No one showed up. Maybe they're frozen out of your house like I am right now. I'm frozen out of my car because of the ice storm, and therefore we didn't have church, and now I'm here and I'm making videos, and I can't get to my vehicle right now. Fewer than 10 children are at the party. So when I look up and I look at how many children could be there, that is indeed less than 10. So W is less than 10 would be my matching inequality, even though you already know it. My third one. No more than 10 people can be seated at a table. No more than 10, but could I have 10? I could, because by the way it's worded, it doesn't say I can't have 10. I just can't go to 11 or 12 or 13. 10 or less can be seated at this table. So let's look at what I have over here. This says S is smaller than or equal to 10, and this one says T is larger than or equal to 10. So I know that that one flows over there. Well, we'll put that one together too. So I'm left with T is larger or equal to 10, but I always want to check my work and make sure I'm correct. At least 10 people need to sign up for the class. So the smallest number of people that can be in a class. Now, this really doesn't pertain to you and me in elementary school and junior high and high school, but when you get to college, if you don't have a lot of students that register for a certain class, or maybe your parents like to go to the Y and work out, and they're doing that bicycling thing, and only 2 people sign up. If the sign says I can only take 10 or more, so only if or at least 10 people sign up for the class, then we'll have it. If they only get 4, they only get 9, they're not going to have the class. So when I know that my number has to be equal to 10 or larger, and I look at how this is set up, T is indeed greater than or equal to 10. Alright, so that's understanding inequalities. It's all about think. You have to think about what it says, read it, think about it, and then apply it. Not a difficult lesson, and it is a shorter video than all the other ones, so you should be able to get through it quickly. And there's fewer homework questions also, so yay you. If you have questions, you'll bring me your book, you'll show me that you did follow along, you were thinking and listening to me when I was talking and learning from me, and then I will be more than happy to answer your questions.